Scott Beal, the Chief Operating Officer for Pathogen Solutions. And first of all, I want to thank you all for your time and attention and attending this show in particular to try to improve your processes and your performance collectively as an industry and individually as your companies. A little bit about myself. I was trained at UPS to be constructively dissatisfied. I worked for 20 years at UPS, and we measured everything. We measured where you put your key when you got out of the package car to make a delivery, so you weren't looking for it and you wouldn't waste any time looking for it when you got back in. Up until 2011, that placement was on your ring finger. And then at 2011, there was the implementation of key fobs that would open the bulkhead door, lock the door, turn the truck off, turn it back on, all simultaneously, saving us a massive 1.75 seconds per stop, or 6 minutes per day. We did those things because we were constructively dissatisfied, and we knew that we needed to keep pushing the envelope for performance. I started in the airline side of things, where it was our responsibility as a startup airline to bring in packages from all over the world and turn those same packages over in about 3.5 to 4 hours and get them back to every destination within the world that same morning. So you can imagine the intensity and the scrutiny on details. So with that, I entered this world through association through UPS with people who had bought this technology and has made me study biosecurity and things of that nature. So I share that with you. Donald Schaffner says, I won't say the food supply is getting less safe, but it's not getting safer. We've sort of stalled out. How many in here, by show of hands, has experienced a recall, knows of a close friend, family member who's been a part of a recall? Just by a show of hands. Okay. In 2013, the cost of foodborne illness, the economic impact, was $15.5 billion. You're seeing on the screen $75 billion in 2023. And that's an increase in 10 years from 2013 to now, a $59.5 billion, or 484% increase in the economic impact of foodborne illness on the U.S. economy. I hear every day as I go out into this world and this industry, we don't have the money to do that. We don't have money to do that. And when I look at these numbers, I wonder, how do we not have? How can we not do? How can we not spend? How can we not try? How can we not push the envelope in every imaginable way? Because the savings in terms of financial savings, negative outcomes and negative impacts to communities and health is substantial. So I challenge us all to come back, as we come back to that later in this presentation, to think about being constructively dissatisfied and how do we say yes versus shutting down innovation because of cost. Here are the top reasons for USDA and FDA food recall in 2023. Nearly 30% of those are transmitted on shoes. And you can see there on the screen, Listeria, Salmonella, E. coli, and Coronabacter. We happen to deploy a technology that eliminates or denatures, would be a better term, Listeria at 99.994% or 4.21 log. Salmonella at 99.9997% or 4.58 log. E. coli 99.997 or 3.56 log. And Coronabacter 99.97 or 3.48 log. There is definitely a need for improvement in the area of reducing the amount of bioburden, entering these clean spaces and facilities where food manufacturing and preparation is going on. the previous gentleman was in, and he had a very compelling technology. If you hear someone talk about responsible science, listen. Making impacts broadly will be a mutual effect of a layered approach using multiple technologies to fight what we're constantly up against. This is an image of a facility currently without any perimeter protection entering the facility. Did you know that a single pathogenic cell coming into a facility replicates from 1 to 1 million in about 6.6 hours? Each person in here has 800,000 colony-forming units of bioburden on their shoes or microorganisms, as studied by the university and documented by the University of Arizona. 96% of those shoes carry fecal matter, and 90 to 99% of that transfers from the shoe to the floor. We've got to eliminate these things from entering our building, because once they are inside, they spread swiftly, broadly, they multiply quickly and rapidly to high-touch surface areas where they can and do cause harm. This just happens to be an example of a facility that's locked down the perimeter utilizing this technology. Again, I'm an advocate for all new technologies that practice responsible science, and that's very easy to determine by looking at the scientific evidence that they have presented to you. So in so doing, we should lock down the perimeter. Anything that comes in that building will spread. Let me give you an example, and it's not a food example, it's a healthcare example. Doctors Koganti and Donsky in 2017 did a study of something on the floor in the Cleveland VA without telling anybody that they were there doing that. They are very respected infectious disease specialists, and they tracked where that microorganism went for 24, 48, and 72 hours. Let's just say it was on everything. It was on the nurses station, 90% of the bed row, 80% of the call button, 90% of the footboard. You can look at the science. It's a very well-respected study with the p-values for statistical relevance being off the chart. So much so that if you're scientific in nature and you look at that, you can't look away from it. So I think that one of the missing links in the integration to keep things out of facilities is to lock down the perimeter. Imagine a faucet, if you will, turned on, and that's what the current environment is. There are other protocols that are in place now for some of those placements. Unfortunately, we'll talk about some of the shortcomings of that in just a minute. You need consistent outputs from what you're doing in that location to keep these things out of your building. This is more of a local example from a poultry operation. These are the typical number of employees that would be entering one of these various facilities or over a course of a year. So 21,900 visits into a typical, as defined by our research, poultry operation, be it the broiler, pullet, breeder, or layer operation. And as you can see, Dr. Louise Dufour Zavala states there is a higher probability of cross-contamination due to increased foot traffic. Let's look at a broader explanation in terms of all food processing. On average, there are 48 employees in an average food manufacturing facility in the United States. With 360 operating days, that's 17,280 visits of just the employees. With 800,000 colony-forming units on their shoes, that's 17,280 visits, or 13 trillion CFUs entering a facility. 13 trillion entering a facility where each one of those can multiply to 1 million in 6 hours. You can see the dilemma. You're completely being overrun with bioburden and multiplication of these microorganisms. Again, Scott, why did you talk about a medical facility? These intruders don't discriminate. They don't care whether you're a healthcare facility, a poultry manufacturing plant, a spice manufacturing plant, a dairy processing facility. They are coming into your facility one way or another. Back to the process side of things. So you want your process to be as repeatable, as consistent, with the most reliable outcomes to lock down that perimeter as humanly possible. Here's an overview of some of the current shoe disinfection models. Foot baths, door foamers, dry clot powders are standard practice, and these rely very much on manual processes. I've been in pizza manufacturing plants where the manager has somebody come off the line and spread clot powder. He goes back to the office, he comes back out, and he says, it's not distributed evenly, you need to go back over here, back over here, back over here. I have walked into facilities with chemical mats that are bone dry. I have walked into facilities with chemical baths that are fully operational. One door had 5 people walk through it, and one door had 5,000. Nobody's monitoring the efficacy and how long that holds up. It creates variability and human error. In many instances, humans have to mix the solution, another variable for human error. A lot of the things are potentially hazardous, runoff into the water, increased slips and falls, and again, in my estimation, the most critical component, inconsistency in accuracy and output. Something I learned at UPS is a system will produce what a system will produce. You can continue to do the same system and work the same system and hope for a different outcome, but that system is going to produce what it historically has produced. The only way to impact that is to change a part of the system. Here are some key considerations for innovative disinfection. Sustainability, low energy requirements, no costly consumables, no environmentally hazardous waste. Efficacy, as I said, this technology or any technology, third-party lab studies are a must. Real-world use cases are a must. Consistency of output is a must. Eliminate variability at every opportunity that you can. Ease of use. There's a lot of labor involved in spreading and mixing and disposing of used chemicals. There's a lot of labor involved in that. You need low maintenance solutions that can continue to produce without ongoing costs and ongoing labor. Plug and play functionality and easy to integrate into any environment. Those are things you should be looking at, starting with science. And once they check off the science block, continue to push forward. Our technology is a unit that uses a combination disinfection of UV and ozone. It's very important that it's a combination disinfection in that the ozone is released in a trace amount that will crack the outer capsid of the pathogen in about the first second of engagement with the unit. That then allows the UVC to get into and denature the DNA of a protein, RNA of a virus much more effectively, limiting regeneration and creating a much cleaner denaturing without that regeneration that I discussed. Back to the process. Systematic and controlled traffic patterns. Anything you can do to limit access and streamline access means one less opportunity for 800,000 units times however many people are coming in that entrance to come into your facility. Again, these intruders are looking for ways into your building, and we are all carrying them with us. Strategically placed disinfection units for shoes will protect the perimeter of your building, thus limiting uncontrolled microbial growth and improving efficacy throughout the facility. So what you're looking at here is a transition area from the dirty side into a clean manufacturing area. The secondary placement that you're looking at here is entrance into your facility. Like I said, everyone is carrying them. There is no discrimination. So if it's coming in your front door and science tells us it moves swiftly, broadly, and rapidly to high-touch surface areas, it's best that we leave that outside. Why? That then improves the efficacy of everything else you are already doing in that facility, because it's got incrementally less to do when it is leaving 99.999% or up to that amount on the exterior facility and not coming inside for you to have to deal with it. Imagine your facility is your home and your family's inside, and there's an army outside. Do you lock down your front door so they can't come in, or do you go in the kitchen and get every weapon you have in the house and fight them when they come inside? Which of those makes more sense? Science is very important. Logic is also important. Logically, that's stuff you don't have to deal with if it never comes in. So I really advocate locking down your perimeter any way you possibly can. In summary, we can and do need to improve animal and food biosecurity. I think we can all agree that a 484% increase in a matter of 10 years is not a good outcome. It's not an outcome that anyone would be shooting for as a goal. So we must collectively do better. And I stand here telling you, as a company, we will do anything possibly with you to help you in that endeavor, because we must do better. Utilizing new technologies. You don't have to broad scale adopt everything, but you can buy limited quantities of whatever you see as scientifically most effective for your operation and fits best, implement it in small places, track it on your own accord. Where we've been most successful, every single time the facility has tracked their own results and seen those results improve. Do that. If you don't do that, you won't get new technologies coming to the market, because this is the way we do it. And ironically, as someone trying to bring new technology to the market, every standard I have to meet, I ask, okay, what is the current standard? You would be amazed at how many times I'm told, we don't know what that is supposed to produce. We don't know what the efficacy is of that. We don't know how many are left behind. We don't know. It's a hard standard to step up to when things that are currently going on are established and implemented. You're increasing burden to the economy 484% in 10 years, and people tend to not want to try something new. I challenge you, I challenge me, because we can do better. I promise you we can do better. We should minimize manual processes as much as possible. We're looking for the root what, not the root who. Managers look for the root who. Leaders look for the root what. What is causing this issue? How do I impact it? Humans are human. You know, somebody that gets the dilution wrong might have 3 jobs, and they're running between one to the other, to back and forth, all for the cost of saving 10 minutes. What about something that doesn't need that or require that, or anything that you can implement that eliminates variability and gets to the root what? Current protocols are just not enough. Again, responsible science says an integrated approach would be most beneficial, coming at this from multiple directions. And then embrace these new innovations, try them. It reduces risk to your employees and to your downlay consumers. It's very easy to verify the results once you have, beta cases in place. And then there's also plenty of technologies with more than enough relevant and responsible science already in place that you could broadly adopt or quickly adopt and feel comfortable about the decisions you're making. One of the negative impacts that happened past COVID was people were inundated with, I have to do something, and 10 million things came to the market that were not scientifically responsible. I will say again and again and again, start with scientific responsibility first. If they cross that hurdle, wave them in, embrace them, and try anything you can to make an impact on an economic burden that is as substantial as what we've dictated and outlined it to be here today. I just want to thank you again for joining us. Thank you for doing your part to try to impact positively your industry and your individual businesses. The fact that you're here means you are very interested in doing that. So I applaud you. I thank you for your time and attention. Back to that responsible science thing that I keep talking about, that's probably spoken of too much from this podium. You can scan that barcode and get every scientific study that we've done. You can go to our website, pathogen.com/more-info, and it will have everything right there for you as members of this show. If you'd like to stop by and talk to us more, we're at booth 46012, just around the corner here, and we would be glad to share anything that we have, be it reference material, technical information with you. But again, thank you again for your time and your attention.